Okay, problem part 5. Prove that if f of g is defined by this, when g is not equal to plus minus pi over 2, cosine g divided by g squared negative pi over 2 squared, when g is equal to plus minus pi over 2, f of g is defined by negative 1 over pi. Then f is an entire function. As already mentioned previous, entire means f has a derivative at any point for a given domain, given set of complex numbers. To deal with this problem, we use the theorem 1 corollary in section 71. F of g can be represented by a convergent series for all g. If we show that this, then we can prove f of g is entire by using theorem 1 and corollary in section 71. Okay, so we just focus on this to prove this statement here. Note that first, f of g is analytic for all g except g is equal to plus minus pi over 2. Then also we are going to use the series of cosine g. Cosine g is equal to negative sine of g negative pi over 2 here. Then we get a series, Taylor series, by using sine g here and here. Then multiply g squared negative pi over 2 squared, 1 over g squared negative pi over 2 squared. We get this result. So, which means this function has a power series, convergent power series here. Let's consider a function g of g, which is defined by the same expression. Just we get right over for all g in some neighborhood u of g is equal to pi over 2, which does not include negative pi over 2. Then g is analytic at g is equal to pi over 2. And let's look at carefully g of g. If we insert pi over 2 to g, then here this term can be expanded like this. Here I wrote it: 1 over g plus pi over 2 times negative 1 over 1 factorial plus something goes something like this. Then if we plug in pi over 2 here to compute g over pi over 2, then these terms are all 0. So we get this part, and g is pi over 2. So this part will be pi. So 1 over pi times negative 1 comes from this. So which is negative 1 over pi. You get this for g of pi over 2 here. Okay? So it is well defined. It's continuous. Okay? So with this series is convergent, which means by corollary in section 71, we can prove G is actually F on U is analytic at G is pi over 2. Okay. For the case of G is equal to negative pi over 2, we can prove it in a same way. Yeah, same idea, just before. Then we get this. So for every case, we show that F is analytic. Yeah. Whatever G is equal to pi over 2 or negative pi over 2, so we can have F is entire. Oh my, okay. Thank you. Time's over. Do you have any question? Okay, thank you for listening. Bye. 질문 있으신 분은 질문하셔도 돼요. 수업 있으신 분은 가도 되고요. 다들 조용히 나가시네요.
감사합니다.
예.
감사합니다.
네, 다음에 봐요.